Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science, MLR Institute of Technology, Hyderabad. I welcome you all with another video lecture on stream processing and analytics. My today's topic is transformation and aggregations. Okay, now let's move on to the topic. So before going into the topic, we'll have a quick overview of today's presentation. So I have divided my overview in two parts. The first part is transformations and what are the different types of transformations we have. And as a second part, we are going to learn about aggregations. So what are these aggregations with related to stream processing? We'll look into it. Now let's move on to the first topic. So first topic is transformations and aggregations. So Spark uses, so we are talking about Apache Spark, right? Which is a best technology in stream processing. So that Spark uses transformations and aggregations. So this uses these main two topics. So those are transformations and aggregations. So what are the transformations first? We are going to learn about what are the transformations first. So transformations are operations. We can say it as transformations are nothing but operations that create a new data set from an existing ones. Okay, transformations are operations that we can apply to one data set, which another data set can be created by using some existing data sets. And aggregations, so aggregating is a process of getting some data together. So as a general meaning of aggregation is nothing but grouping, some things. So here aggregation is nothing but process of getting some data together in as a cluster, and it is considered as an important concept in big data analytics. So it is a main important part in data analytics. So transformations are computations that express in the same way for every element in the stream. So these transformations with related to each and every element, those express the same meaning. For example, creating a derived stream that doubles 2 times every element of its input stream corresponds to a transformations. So here, if we take one element as an example, it will doubles the elements. So here we can say it will in 2 times it will doubles. Aggregations. So aggregations on the other hand produces results that depend on many elements. Okay, here if one aggregation we perform on any elements, it will produce many elements as an output. Every element of the stream observed until now. So how many times the element the system is going to observe, that many elements will get it as an output. For example, collecting the 5 top elements of a largest numbers of an input stream, average value of some reading every 10 minutes are examples of aggregation. Suppose if we take a larger number of some elements, so out of all the larger number of elements, we can collect 5 largest numbers, right? So which is nothing but aggregating out of some number of elements. So here we are aggregating as a 5 elements. So out of multiple elements. So that is nothing but aggregations. Now let's move on to the next slide. So Spark streaming and structured streaming uses a series of transformations applied to immutable input streams. Here Spark streaming and structured streaming are two streaming processes which was offered by Apache Spark. Okay, as I have told you in the previous slide, Apache Spark provides Spark streaming as well as structured streaming. So here transformation functions are applied as a fundamental data structures in these two particular streaming processes and produce an output streams. So by using these transformations, we can produce an proper output. So Spark transformation is a function. Here we can say Spark transformation is nothing but it is a function that produces a new RDD from an existing RDD. Okay, now let's look into the RDD. What is RDD? So RDD, which means that resilient distributed data set. Okay, RDD is nothing but resilient distributed data set, which is a fundamental data structure in Apache Spark. Okay, Apache Spark. As a input and output, we will work on RDD. So we can call it as fundamental data structure of an Apache Spark. So it takes RDD as an input. So here as a data source, if we talk about stream processing, okay, this is a data sink, right? So and this in middle there is a stream engine. So here as an input, it will take one RDD. Okay, RDD is nothing but resilient distributed data set. Okay, it takes an input as an RDD, produces one or more RDDs and output. Okay, based on the transformation functions, it will produce one RDD as an output, or it will produce multiple RDDs. Okay, multiple RDDs based on some transformation functions and based on the scenario. Okay, we will look into it in a minute. Okay, now each time it creates a new RDD when we apply any transformation. So okay, whenever we apply transformations, each time it will create another RDD by using existing RDD. Thus the input RDD cannot be changed since RDDs are immutable in nature. So we have seen in the previous slides immutable streams, right? The meaning of immutable nothing but unchanged, right? Once the input is generated as an RDD, we cannot change the existing RDD or input RDD. Instead, it will create a new RDD. It will create a new RDD with new objects. Okay. Instead, it will create a new RDD with another new object, which is nothing but immutable property, which Apache Spark follows. So, what is the use of immutable streams? If we use in Apache Spark which means that we may not lose the original content. Okay, we may not lose the original content. So original content may be as it is. Okay, no need to change the existing input. Another way to express those ideas is to say that transformations have narrow dependencies. Okay, what is the general meaning of narrow? Means which is very less, right? Less in size. Narrow, which means that narrow. And what is the meaning of wide? Which means that it spreads through wider areas. Okay, here transformations have narrow dependencies, whereas aggregations have wide dependencies. If we differentiate between transformations and aggregations, what is the main difference between these two is transformations are narrow dependencies and aggregations are wide dependencies. Okay, wide dependencies. What are these narrow dependencies and wide dependencies? Means where aggregations have wide dependencies, which means that what is the meaning of narrow dependency? Means to produce one element of the output, you need only one element of the input. Okay, to produce one element, suppose if we take this is one element. Okay, to produce one element as an output, input and output, we require only one RDD and one output RDD. But if it comes to aggregations, to produce one element of the output, you need to observe many or all the elements of the input stream. So here, if you want to perform aggregate function on this input stream, okay, as an input, it will observe more RDDs. As an input, it will observe more RDDs to produce one RDD as an example. Okay, one RDD as an example, it will take multiple elements of a input stream. That is the difference between transformations and aggregations. Now let's move on to the types of transformations. Okay, so now we have gone through what are the transformations. Now we will look into how many types of transformations we have. Okay, transformations are lazy in nature. Okay, what does it mean? Lazy in nature means they get executed when we call an action. When we call an action, then only these transformations are applied on each element. Otherwise, those are lazy. Okay, they are not executed immediately. Okay, unless and until we can call the action, those transformations are not going to execute it, which means that we can have a storage, we can improve storage. Yes or no? By using this feature, lazy evaluation, there is a chance of increasing, unnecessary storage of the data. So there are two types of transformations, as I have told you. So the first one is narrow transformation. Second one is wide transformation. Okay, narrow transformation and wide transformation. As the name suggested, okay, these have related spaces. In narrow transformations, all the elements that are required to compute the records in a single partition will be present in a single partition of parent RDD. Suppose if I take one RDD as an input RDD, okay, here this one is parent RDD, which means that this is an output RDD I can see, and this is an input RDD. So if I all the elements, how many elements we have in this input RDD, okay, has to present in only parent RDD, okay, only parent RDD, and it will not go to another RDD. These input streams cannot apply to another parent RDD2, okay, parent RDD2. So we will look into this in a while. Narrow transformations are results of map and filter, okay. The results of narrow transformations are nothing but map and filter functions. And when it comes to wide transformations, in wide transformations, all the elements that are required to compute the records in a single partition may be present in many partitions of the parent RDD. Suppose if we take one input RDD, okay, so these all the elements are belongs to all the parent RDDs, okay, parent RDD1, parent RDD2, parent RDD3. So there may be chances of going all the elements in all the RDDs. Maybe it is a cross, okay, this we can call it as a cross processing, okay. Wide transformations are the results of group by and reduce by. These two are the main functions used in wide transformations, okay. So now let's move on to the, what are the narrow transformations and what are the wide transformations, and we will look into the picture. So here if I say this is one RDD and all the elements in this RDD only have to present in the parent RDD, okay. Here they have represented in a color, okay. The blue color, these are the elements of RDD1, red color elements are RDD2, and green color represents RDD3, okay. Here if you see as an input RDD, I have taken first RDD which is represented in blue color has to present in only parent RDD which is represented in blue color. So it does not belong to all the other RDDs which are represented in red and green, okay. So here each and every element, input element RDDs belongs to that parent RDD itself. So examples of narrow transformations are map function, flat map, map partition, filter, sample and union. When it comes to wide transformations, here we can see into this picture. Here the blue color represents RDD1, red color RDD2 and this is RDD3, okay. Now the elements of RDD1, there is a chance of existing in all the other RDDs as well, okay. All these are parent RDDs, okay. There is a chance of, crossing in all the RDDs. There is a chance of existing in cross system, right, okay. Here there is a chance of existing in RDD1, RDD2, RDD3. So it will allow in cross system. So intersection, distinct, reduce by, group by, join, Cartesian, repartition and coalesce are examples of wide transformations. So now we'll look into the examples of some basic RDDs functions. So we'll go first with a map. Map is one of the narrow transformation function, okay. The map transformation applies a function to each element in the RDD. So we can apply map a function to each element of an RDD, okay. Returns a new RDD, okay. If you apply a map to each and every element of an RDD, it will create a new RDD representing the results. So as I have told you, one RDD creates, input RDD creates and another RDD as a result. So here is a basic example we can see as a syntax, okay. Here I have created data, okay. Data is my RDD, okay. Parallelize method, SC is nothing but here Spark context, okay. Spark context. Before dealing with the RDDs, we have to create Spark context, and val is nothing but it is a similar to variable name, okay. which is other programming languages we have, right? Variable name. Val is nothing but variable name. Here, what is our variable name? Data is our variable name. And SC is nothing but before dealing with the session, we have to create Spark context. Then only we may get a chance to access RDDs. And parallelize method, and I have taken array. Okay, array of 4 elements, 1, 2, 3, 4. So here, as an input, I have taken array of 1, 2, 3, 4 elements. So these elements here I have applied map function. Okay, if I applied map function, this array will be stored in RDD1. Okay, this array must be stored in RDD1. So after applying map function, the RDD1 will create a new RDD which will store my output. What is my, here I have taken squared data. So squaring of each array. Okay, I have applied the logic of squaring. Okay, here x implies x into x, which means that square each and every element of my array. So here that result may be stored in another new RDD. So 1, 4, 9, 16. As a result, if I apply map transformation on RDD, it will create a new RDD as an example. Okay, now let's move on to the filter function. Okay, filter is nothing but we can say it will work based on some condition. Okay, some condition, based on some condition, my filter function works. The filter transformation is used to select elements of the RDD. It will use to select the elements, some particular elements from my RDD that meet certain criteria, which means that some certain condition. It has to, for selection purpose, RDD function or RDD filter function has to meet some criteria. So here we can see with a simple example. Again, I have created an array of 1, 2, 3, 4. So here I have applied the logic even data. Okay, even data. What is my logic here is x implies x percentile 2 equal to 0. Okay, here if I apply this logic by using filter function, which means that it has to meet this particular criteria, which means that the elements of my array has to divided by 2 equals to 0. So I have to get 0 as an output. So how many elements I can get as a result here? So 2, 4. Okay, as a result, if I meet this particular criteria, as a result, I may get 2 elements. Why? Because 2 by 2 is 0. If I divide 2 by 2, the output is 0, and 4 by 2 is, 4 by 2 percentile is 0. Okay, so in the same manner, it has to follow some criteria. And when it comes to flat map, what is the using of flat map transformation? While map applies a function to each element individually, flat map can produce multiple output elements for each input element. Okay, so there is a small difference between map transformation and flat map transformation. What is the difference? Okay, here we can apply map to each and every individual elements, but flat map we can produce multiple outputs. It will produce multiple outputs as an multiple elements as an output. Okay, here is an example. Suppose here I have created the variable of words list. Okay, here I have created a words list in a sequential manner. So here string data I have taken. Hello world is my data and how are you? So if I apply flat map function, it will split each and every map function. Flat map function works with the split function. It will works parallelly with the split. So here, if I apply for flat map transformation, it will applies to each and every element. Okay, each and every element, and it will produce multiple elements as an output. Okay, how is one output? Hello is one output, world is one output. Okay, like that it will produce multiple words as an output. So that is a similar change. That is a small difference between map and flat map. Okay, now let's move on to the next transformation, the union transformation. Okay, the union transformation merges two RDDs. Okay, as the name itself suggests, union is nothing but grouping the data, right? So here two RDDs comes together. Here is how we can do it. So by example we can do it. So here I have created RDD1. Okay, why? Because to grouping two RDDs, we have to take two RDDs, RDD1 and RDD2. So my RDD1 elements are 1, 2 and 3, and my RDD2 elements are 4, 5 and 6. So after applying union function on RDD1 with respect to RDD2, it will add RDD2 to RDD1. Okay, it will add RDD2 elements to RDD1 element. So as a result, here we are getting multiple elements as a series. Okay, now let's move on to the next transformation. The next transformation is subtract. Okay, subtract transformation returns an RDD with element from one RDD that are not found in another. Okay, that are not found in with respect to two RDDs. Okay, two RDDs, the different elements. Okay, when compared with these two RDDs which are not found in one RDD, those elements are going to return in subtract transformation function. So here, to compare for two RDDs, we need to take two RDDs as an example. So here I have defined two RDDs. 1, 2, 3, 4 is one RDD. 3, 4, 5, 6 is another RDD. So here if I apply subtract function with respect to RDD1 and RDD2, it will write which are not present in RDD1 and RDD2 elements. Okay, so here with respect to RDD1 and RDD2, array 1, 2. Okay, here 1, 2 are not present in RDD2. So here the output I may get as 1, 2, array of 1, 2. Why? Because 3, 4 elements are already existing in RDD2. So now subtract transformation works in this manner. Next, the next transformation is intersection. So intersection, as it is nothing but intersection between two RDDs. So transformation returns a new RDD that only contain elements found in both sources RDDs. Okay, here it will take two RDDs again, RDD2. So here as an intersection element, it will write the similar element in both RDDs. Okay, both RDDs. It will write the similar element which is present in both RDD1 and RDD2. That type of elements it will write as an example, write as an output. Okay, here we have defined RDD1 and again RDD2. RDD1 with respect to intersection and RDD2, if we apply the logic on RDD1 and RDD2, it will write as an output only 3. Why? Because 3 is existing in RDD1 as well as in RDD2. So it will write the similar element in both the RDDs. Now comes to distinct. Okay, distinct transformation removes duplicates in an RDD. So here distinct, the meaning of distinct is nothing but different. Okay, different. So here which is nothing but duplicate. Okay, duplicate. So here how we can see it with a small example means, here I have created one RDD 1, 2, 3, 2 and 3. So here if we apply distinct transformation, it will overwrite duplicate. Okay, it will write only one time. Okay, duplicate values I have 2 times, right? 2, 2 exists 2 times, 3, 3 exists 3 times. So this will write only one element and it will remove another duplicate value. So here as an output I got 1, 2, 3, 4. So okay, as an output we may get out of 5 elements we got only 3 elements. So like this distinct function works in Spark. Now we'll see another RDDs which may have key value pairs. Okay, which may have key value pairs, and we can call it, these functions are aggregations. Okay, we can call it as aggregations. Why? Because these works based on some group. So one of the main aggregation function is reduced by. Okay, reduced by. So here the reduced by transformation aggregates. Okay, the reduced by transformation aggregates the value for each key. Okay, it will work based on key value pair. Okay, key value pair, as already we know, every key has their unique, every key has their value. Okay, suppose I have a name, so here it has Akash. Okay, I can write Akash. So name is, call it as key, Akash is nothing but the value for this key. So here reduced by transformation works based on key value pair. So it will aggregate based on some key using an associative reduce function. Okay, it will work based on reduce key with its associate functions. Here is an example. Okay, here I have taken again as a sequence. So here my values are, first key is apple, and for that I have value of 2. Second key is key 1, key 2, key 3, and the value for second key is 3, and my value and key of 3 is apple, and for that value is 1. So based on the key, this reduce by function will reduce the similar keys. Okay, will reduce the similar keys. As you can see here, as a key 1 and key 3, I have the same name, right? Apple. Okay, as my key. So I can reduce these 2 by 1 element, right? So here I can add this 2. So here what is the number of first value? 2 plus 1. So I can add here as a aggregate function. So here my apple has value 3. I have added 2 values because it has a similar keys. So if I apply reduce by, it will work with respect to aggregate. It will add the first key value and second key value if the two values are, key values are same. Okay, now let's move on to the next transformation. So the next transformation is nothing but group by key. As the name suggests, group is nothing but grouping based on some key. Okay, the group by key transformation groups the values for each key in the RDD into a single sequence. Okay, based on key value it will group. Okay, based on key grouping the values, and it will add based on the key and value. Note that reduced by is often a better choice as it has better performance characteristics. If we compare with the group by and reduced by has some better performance. Here how the group by works means, here I have defined one again sequence. Those my sequence values are apple. Okay, it has a value of 2, orange 3, and here apple again 1. So here what is the difference between reduced by and key? Here I have added which has the similar keys. In by using reduced by transformation I have added these two as a 3, but here when comes to group by it will show individually 2, 1. Without adding it will show individually. So as an output here we can see array of apple which has the similar keys and the sequence of 2, 1, which means that it has 2 value as well as 1 value. So as a part of 2 and 1, the key value is 1, only apple. Okay, so it will write combination of 2 values. Next comes to sort by key. Okay, sort means based on some values it will sort. The sort by key transformation sorts the RDD by key. Okay, here the sorts transformation functions will sort the keys or RDDs by using the keys. Here is an example. So here I have defined again the same, apple as my key and 2 as my value, orange as my key and 3 as my value, banana as my key and 1 as an value. So here if we observe here sort by key, okay, based on the key it will based on some key. So what are my keys? A for apple, O for orange and B for banana. So based on this alphabetical order it will sort in with respect to order. Okay, here I have written after applying sort value A, B and O. Here if you observe the output based on the key value it has sorted in alphabetical order. Okay, alphabetical order. So each and every function works with respect to their functionality. And as a part of our transformation function, the last transformation function is nothing but join. Okay, the join transformation. Okay, join is also we have applied on two RDDs. Okay, two RDDs by keys. Join is also works with two RDDs with respect to keys. Here we have a small example. So as a part of RDD1, here elements are apple, my key is apple and value is 5, key is orange and value is 3. So this is a RDD1. Okay, next RDD2. As a part of RDD2, I have my elements as apple as a key, 2 as an value, orange as a key and 4 as an value. So here the join transformation function will work with respect to RDD1 and RDD2 in this manner. Okay, here apple has, in RDD1 apple has a value of 5 and in RDD2 apple has the value of 2. So join function will join these two key values which are similar from two RDDs. Okay, two RDDs. So here as an output, here if we aggregate these two values, so our output is apple 5 comma 2. Why 5 comma 2? Because I have a value of 5 in RDD1, value of 2 in RDD2. Okay, in a similar way, the key of orange is also aggregated in a similar manner from RDD1 to RDD2. So here that is the reason here orange has 3 as a first value, 4 as a second value in RDD1 and RDD2. So here join function has joined the values of each and every keys. Okay, in this manner the join function will operate on each and every RDD. So all these functions are applied on RDDs with respect to Spark. So thank you so much.